Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering tribology subject. So in this subject, friction, wear and lubrication, these three parameters are very important. In previous sessions already we have studied about this friction and wear and lubrication and also corrosion. So how to reduce the corrosion and testing methods. So similarly like that types of friction, types of wears we have learned. So in this session, so we will see the engineering materials. So what are the engineering materials and how many types of materials are there? So which material is suitable for a particular application? So like that, before selecting the material, you should see the properties of material. Which type of properties are required for a particular application? Suppose if you want to design engine, so which type of material is required? What are the operating conditions? And then what are the environmental conditions? Which type of load is acting? So what are the forces acting on that particular element? So all these things depends upon this material selection. So that's why you should see the quality of materials. Is it the selected material is withstand or not for particular application? So like that you have to see. So that in this session, first we will we will see the engineering materials introduction and then types of materials one by one we will learn. So first of all, in the introduction part, the engineering materials are the fundamental substances used in the construction and manufacturing of various products and structures. So main the engineering materials you may use in construction and manufacturing of various products and structures. These are the material is the main substance. These materials are selected based on their properties. Already I told you. The selection of materials depends upon property and suitability for specific applications and availability also. And cost point of also, in cost point of view, you should see is it the selected material is reliable or not. So ranging from everyday objects to complex industrial components. So from daily used objects and products to industrial components. The field of engineering materials encompasses a wide range of substances including metals, polymers, ceramics, composites and semiconductors. So all these the substances including these metals and polymers also. Here some of the key categories given. The first one is metals. So you know the engineering materials are classified into two main categories. One is metals and non-metals. So the metals are known for their strength, ductility and conductivity. These are the mechanical properties. Common metals used in engineering include steel, aluminum and copper and titanium. They are widely used in structural applications, machinery electrical wiring, and transportation vehicles. So mainly these metals used in structural applications, transportation vehicles. Next one is some of the key categories, polymers. Next one, the polymers are large molecules composed of repeating units called monomers. They are lightweight, corrosion resistant, and offer a high degree of design flexibility. These three uh, are main properties of these polymers: a lightweight and corrosion resistance, and offer a high degree of design flexibility. The examples of polymers include plastics, rubber, and then fiberglass. They are used in a variety of applications such as packing, automotive components, and medical devices. So used in many applications like in packings and automotive components like a piston, connecting rod, and then other the wall materials. So used in these automotive components and medical devices also. Ceramics. Ceramics are inorganic, non-metallic materials known for their high hardness, heat resistance, and electrical insulation properties. Examples include porcelain, silicon, silicon carbide, and aluminum. The ceramics find applications in electronics, aerospace, and the production of cutting tools and refractory materials. Composites. Composites are materials made by combining two or more distinct constituents to achieve specific properties. They often consist of a reinforcement phase, such as fibers or particles, embedded in a matrix material, such as a polymer or a metal. The carbon fiber reinforced polymers and fiberglass reinforced plastics are, are common examples of these composites used in aerospace, automotive elements, and then construction industries. The carbon fiber reinforced polymers (CFRP) and FRP fiberglass reinforced plastic. So common examples of these composites, mostly used in this aerospace and automotive industries. Next, semiconductors. The semiconductors are materials with electrical conductivity between that of the conductors and insulators. They are essential components in electronic devices such as transistors, diodes, and integrated circuits. Silicon and germanium are the most widely used semiconductors in the electronics industry. Next, understanding these properties, processing methods, and performance characteristics of engineering materials is essential for engineers and designers to select the most suitable materials for specific applications. So this point already I told you in the first slide. So understanding the properties and the manufacturing methods, the processing methods, and the characteristics of engineering materials is essential for designer engineer before selecting the material. So optimize product performance and ensure safety and reliability also you should concentrate. Next, advanced alloys typically refer to materials that are engineered to have superior properties compared to traditional alloys. These properties can include higher strength, improved corrosion resistance, better heat resistance, enhanced electrical conductivity, or a combination of these characteristics. So this Advanced alloys include higher strength, improved corrosion resistance, better heat resistance. So you can improve the electrical conductivity. So you can combine all these characteristics. These alloys are often developed through advanced metallurgical techniques and may incorporate elements like titanium, nickel, cobalt, chromium, and other imprecise compositions. Here, some examples of advanced alloys given include titanium alloys, nickel-based super alloys. So, known for their high strength to weight ratio, corrosion resistance, and biocompatibility, titanium alloys are widely used in aerospace, medical implants, and chemical processing industries. The titanium alloys are used in this aerospace and medical implants. And some chemical processing industries also use these the titanium alloys. And nickel-based super alloys, these alloys offer excellent high temperature strength and oxidation resistance, making them ideal for gas turbine engines in aircraft and power generation. So nickel-based super alloys generally used for this aircraft and power generation. So these two are examples of advanced alloys for particular application. There's two more given: stainless steel and shape memory alloys (SMEs). So advanced stainless steel are designated in this. Actually, the advanced alloys, one is stainless steel and shape memory alloys. So these materials are designed to withstand extreme environments, such as those encountered in offshore oil drilling, chemical processing, and food processing industries. The main industries applications are food processing and chemical processing. Shape memory alloys. These alloys, such as nithanol, nickel, titanium, naval ordnance laboratory, have the unique property of returning to a predetermined shape when heated. They find applications in medical devices, actuators, and robotics. Some more examples: high performance alloys for additive manufacturing. It's nothing but 3D printing. So there is a growing interest in developing alloys specifically optimized for this process, offering improved mechanical properties and design flexibility. The refractory materials are tungsten, molybdenum, niobium, tantalum, and rhenium are examples of refractory metals that can withstand high temperatures and harsh environment, making them essential in aerospace, defense, and high temperature applications. These are the refractory metals. So the refractory metals can withstand high temperatures. So that's why in furnaces, the furnace walls are made with these refractory metals, refractory materials. Why? Because they withstand high temperatures. So these advanced alloys play a crucial role in various industries where performance, reliability, and durability and paramount. Their development continues to advance with ongoing research in materials, material science, and engineering. Next, super alloys. The super alloys, also known as high performance alloys, are a class of materials designed to maintain their mechanical properties at high temperatures, making them ideal for demanding applications such as aerospace, power generation, and chemical plants. These alloys typically exhibit excellent resistance to corrosion, oxidation, and creep. The gradual deformation of materials and under constant stress and high temperatures. So one of the most well-known superalloys is inconel. So a family of nickel, chromium, and based alloys that are highly resistant to corrosion and oxidation, even at exposure to elevated temperatures. The other examples include astolai, Vaspalai, and Rens alloy and margin steel. These all are superalloys. The superalloys are crucial in industries where materials are subjected to extreme conditions, such as the hot, corrosive environments inside jet engines or gas turbines. So their ability to withstand these harsh conditions makes them indispensable for ensuring safety, reliability, efficiency in various critical applications. The superalloys are so such as these alloys are subjected to extreme conditions like too much hot and too much corrosive environments, that is exposure to wet conditions, exposure to sunlight. So these are an environmental factors inside jet engines or gas turbines. So their ability to withstand these harsh conditions makes them indispensable for ensuring safety, reliability, and efficiency in various critical applications. So these material having these properties. So like this, the materials are classified into various types, and they're according to the uh, type of application. So that's why before selecting, if you want to design any object, so before designing, you should select the proper material for right application. So then only the product will be success in a market. So that's why, so the engineers, you should idea, you should learn the all properties of a particular materials, metals and non-metals like polymers and polymers, alloys, superalloys, advanced alloys. Like this, you should understand the properties of the particular metals. So then only you can apply the right material for a right application. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.